In our last video, I covered how to create a Kubernetes cluster for home. In this video, we'll follow up by creating a persistent storage class that uses ZFS, serving out NFS volumes for Kubernetes. So let's get started. Let's take a look at the block devices that I will be using. As we can see, I have 5 1.8 terabyte disks that are available in the system. I will be configuring these to use RAID 10 with one hot spare that will automatically replace any failing disk. Let's create the pool using zpool create and passing the A-shift option. This is due to most modern drives incorrectly reporting their sector sizes. Next is the name of the pool, storage in my case, and then the mirror sets, one having SDA and SDB, whilst the other has SDC and SDD, leaving the remaining SDE as a spare. Once the pool is created, we can see the mirrors in zpool status and the storage stats for free space. Now we have a pool, we need to create a ZFS volume, specifying the pool and a name. Using list, we can now see our volume. As I will be using this for a storage class location in Kubernetes, and there is a high chance that most of the data will be compressible, I will turn on compression for the volume using LZ4 as it has a low CPU overhead. I will also turn off A time or access time as I only need the modified time for files in the storage system. Now on to NFS. The system has all the NFS server tools already installed with no other configuration, and if we run the export fs command, we can indeed see that there are no exports. To turn on NFS for our ZFS volumes, we need to set the share NFS setting on the volume. We can now see the setting is applied against the volume, and checking export FS, we can now see the volume is exported. As this is my test cluster, it is very insecure and not how you would set up a production cluster. Persistent storage in Kubernetes. Let's take a look inside the ZFS storage volume. It is empty as we have not configured Kubernetes storage. I will be installing Helm so that we can install the storage class for the NFS provisioner. To do this, I will use a single command line that will download the script from the Helm source repository and run it. Next, we need to install the repository for Kubernetes SIG, NFS external provisioner. However, Helm will not use the repository until it has updated its local cache. Now that that has finished, we can move on to installing the provisioner. I will use the following command, setting my NFS server and the path to the storage. Taking a look at our storage provider, we can see that it is set up, but is not the default. To change that, I will patch the storage class and set it to default so that I do not need to set the metadata on any further PVCs that I provision. Now we will deploy both a PVC and a deployment to use it. Starting with the PVC. This configuration, we can see that I am making a PVC with the name of test claim and setting it to read-write many and allocating 1 gig of space. Although it should be noted that NFS storage, the size is not important as all PVCs share the same directory on the underlying NFS volume. Let's deploy this YAML. We can now see the PVC is listed, and taking a look inside the ZFS volume, we can see our PVC with the namespace, PVC name, and PVC identifier. Next is a deployment that will use the PVC and when started also create a single file. Taking another look into the file system, we can now see the file that the pod created. The NFS provisioner has one more trick. When we delete the pod and the PVC, its underlying storage is still retained. However, it is renamed and appends the word archive to its volume name.